Welcome back. Now let us start using inbuilt blur functions, and one of the very common function is cv2.blur. It is just exactly same as above. If you see here, we had our image, and we did the convolution on this kernel. Kernel is our 3x3. Okay, so in case of this one, cv2.blur is exactly the same. Okay. Gaussian blur, it takes a Gaussian kernel. Gaussian kernel, what is the meaning of that? It gives the more emphasis on the neighborhood, and then average the pixel using the Gaussian kernel. That is the Gauss kernel. That is not a simple kernel. Median blur, it's also kind of, see, this is also known as a sometime mean blur. Median, where it is taking the median, that is the middle point, and it is helpful in removing the really salt and pepper kind of noise. So where you have the little bit of that white dots here and there, it helps in removing those kind of noise. Okay. Now let us go ahead. In 48, we are just resizing the image to little small, so that at least we can see all these three blur in one go. 51, we are calling the blur function. Here we have to pass image and only the kernel size, that's all. In the previous one we had defined ourselves. Here we can say 3x3, 5x3 and so on. Gaussian blur, it is that kernel plus it is the sigma as well. So you can see that help as if you put the help, you will come to know the parameter. Median blur, that's also simple as that mean blur. So all these three we are running together, 51, 52, 53. So I have run it, and let us see in 55 and 56 all three in one go. So if you see this one, this is our original image, and this is the somehow, yes, I agreed little bit of it's not that much clear. So what I suggest, and this part is your mean blur, that is common, and this second part is your Gaussian blur and median blur. I know that see, you may find little bit difficult to understand this picture in the beginning, but if you see the one thing, this median blur, which we have said that it will remove the salt and pepper noise. All the white, not all the white, but maximum white dots have been converted to black. This was the blur which you have seen earlier. Gaussian has blurred, but the quality of image is still good. It means it is not that sharply blurred. So depending upon the situation, you can use any one of these three. Okay, now let us see if you want to go ahead with directional, so like horizontal, vertical, or in any angle and so on. So let us see how we can do. 60, 61, we are reading the fresh image and making it gray. So horizontal means that the zero which you see, let me run it first and show it to you. See, the zero which you see, if a zero is in the horizontal direction, then it is a horizontal impact is there. Okay, at least one of the zero must be there. More zero on the horizontal direction, it is the more impact. Okay, and now what we are doing, this convolution of the two dimension on our image with horizontal image, and let us see. 60C is doing convolution, 68 we are making list, and 69 we are seeing it together. So this is what we have done. This is our horizontal, and horizontally it has been blurred. Horizontal this direction. Okay, so this has been blurred horizontally, and if you see what some changes, if you are able to see, it has a little bit blurred definitely, but in horizontal direction. Okay, and similarly, if you want to do it in a vertical direction, the direction of zero, simply change it, it will become vertical. You change the direction of zero, it will have the more impact in that particular angle as well. If you want to see the larger impact, so use the bigger kernel. Here we are using 3 by 3. All these are 3 by 3. So it is a bigger kernel. And at one place I had seen this is also one of the kernel to basically have the different impact in a proper direction way. I'll request you as a class work, use this kernel and see the impact, and please write on the discussion forum what is the impact you saw. Line 72. Okay, so that's all for the blurring using a standard function. Those have been provided in OpenCV. Good enough. I hope you have understood. Thanks a lot for watching. See you in the next one.